Hello, my name is Rob Reynolds, and we're teaching section 1.6 today, college algebra. And so today we're going to be looking at inequalities and absolute value. So the last section we talked about inequalities, and now we're going to talk about absolute value. And the definition of the absolute value is a little bit tricky. It actually says the absolute value of x is actually equal to x sometimes, but sometimes it's equal to negative x. And I know that bothers some of you because you're thinking, no, the absolute value of 5 is a positive number, and the absolute value of negative 5 is also positive. So how could I ever say that the definition has anything to do with a negative sign? Well, notice that if I let x be negative 5, this is actually then written the opposite of negative 5, which is back to positive 5. So instead of saying negative here, we'll read this sign as the opposite, because the opposite of a negative is back to positive. So keep in mind, the definition is kind of unclear, but the absolute value of x, it could be x for those positive values, but it could be negative x if x is negative, or the opposite of x if x is negative. So again, the absolute value of a, it could be positive for those values that are positive, but the absolute value of a could be negative if a is negative. Again, this is pronounced the opposite of a negative number, which is back to positive. So our first example is x minus 3 could be 10, or x minus 3 could be negative 10. Again, I'm talking about the value of the absolute value could be 10, or it could be negative 10. And I'm going to work out two separate problems here. So if I add 3 to both sides, x is 13, or x is negative 7. Over here, we want to isolate the radical first. Well, it's not a radical. Isolate the absolute value first. So if I was dealing with radicals, I'd do the same thing. So it's the same rule. Try to get that by itself first. So this is the absolute value of 2x plus 1 is equal to 10 if I add 3 to both sides. And then I'll do the same process. 2x plus 1 equals 10, or 2x plus 1 equals negative 10. Same process as before. I say, hey, the absolute value could be 10, or the absolute value could be negative 10. So finishing this up, I get 9 halves, or let's see, what is that, a negative 11 halves? So again, two answers. So I'm going to be solving some inequalities here. This is a less than sign. Remember, less than points to the left because you can make the word less and left from those less than signs. But I'm going to do a play on words here. We're going to pronounce this from this day forward less and instead of less than, because I want you to think of this being an and statement. And statements are also known as between statements. So and statements look like this. They're in between, all the solutions in between some a and b value. And I'm shading all of those because it could be greater than this and it needs to be less than this at the same time, so it just gives me this little interval in between a and b. So again, this says the absolute value, x could be 4, and I'm going to reuse the word and because this is a less and symbol, and x could be something negative 4. So x could be less than, because it is. So basically I just kind of keep this x is less than 4 the same. I just drop the inequality. But then remember, if I choose a negative sign, then I need to flip that inequality. So if I multiply or divide by a negative, that inequality sign is going to flip. We learned that in the last section as well. So the less than sign needs to flip to a greater than sign, simply because when I start dealing with negatives, that's the case. We can look at that really quick. If 3 is less than 4, if you multiply through by a negative 1, then I end up with negative 3 and a negative 4, and notice that the sign is going to flip, because this time negative 3 is actually greater than the negative 4. So that's the purpose of flipping this inequality sign, because I'm changing the 4 to a negative 4. So to graph this, I want all the values of x that are less than 4. It's an open dot. And and all the values that are greater than 4. Well, instead of using open dots, we're going to use interval notation. So we're going to start using parentheses, and I'm going to say I want everything in between 4 and negative 4, and you can write this in interval notation. So this is inequality notation here, and here in blue is interval notation, and you should feel comfortable with both. This is the graph of it. So the final answer looks like this. You should know how to write this as a between statement, and you should know how to write this as an interval. All right. So this next example, it looks like we've isolated this by itself. Again, this is a less and statement. So I already know that the graph is going to come together. Even before I begin this, I know that I'm going to be looking at some interval in between A and B. To find out what that interval is, I say 2x plus 4 is less than or equal to 3. That's the same. I just dropped the absolute values. I'm going to use the word and again because this is a less and sign. 2x plus 4 is greater than or equal to, this time, negative 3. So finishing this up, I'm going to subtract off 4. I don't flip the sign when I subtract 4, only when you multiply or divide by a negative. So x is less than or equal to 1/2. Subtracting off 4, and x is greater than or equal to. Now I know I have a negative here, but I'm only dividing by 2, so I don't flip the inequality sign. So this is around 1/2. It's a closed dot at 1/2. It's a between statement. So I'm going to say, well, 1/2 is about here. And I'm going to use a bracket because it's equal to it. And then negative 7/2 is around negative 3.5. And it's a between statement. So I'm shading all those values in here will make this statement true. Everything in this red section will make this statement a true statement. To write this as an interval notation, I would say everything between negative 7/2, putting the lower number on the left, negative 7/2 up to negative 1/2. And notice, instead of parentheses, now I'm using brackets because I can include those values. Same situation here. 1 minus 4x is less than 5, and, because it's a less and, 1 minus 4x is greater than negative 5. I'm doing the same thing I did before. Absolute value said it could be 5 or it could be negative 5. Just make sure that you're flipping the inequality sign from a less to a greater because you're taking the opposite of 5. So over here, if you subtract off 1, we're going to get a 4. Now this time, if you divide through by a negative 4, that will flip the sign again. So this less than goes to greater than negative 1. And over here, what do we get? Negative 4x. That doesn't look like negative 4x will equal, what's this, negative 6. So x is, if I divide by a negative, that'll flip this greater to a less than. 6/4 is really 3/2. So I want all the values between, it needs to be greater than negative 1, less than 3/2, and everything in between. Again, you should be able to write this in interval notation. Okay, so looking at this next problem is our first example of no longer a less and, but now I'm going to pronounce this a great, again, a play on word, a great or. I know it's supposed to be greater, ER, but I'm going to pronounce it great or because or statements say it could be everything over here or it could be everything over there. So instead of in between, these are the opposite of in betweens, going in opposite directions. So x is greater than 3. I'm going to use the word or this time instead of and. X is a less than, still flipping the inequality sign from greater to less, negative 3. And so the or statements would say parentheses this time because I can't include the value of 3. And it's going in opposite directions. To write this in interval notation, I'm going to say, this goes from negative infinity up to 3, and then over here goes from 3 to infinity. Sometimes they use this word or in here, sometimes they use the U, which stands for the union. It's set notation, and you can remember that's the or statement because you can almost write the word or. You can almost see a U. Some of you are going to ask, what does this symbol mean? It's the intersection. You won't use this. but this is actually the and statement. You can remember that because I can almost write the word and. But you're going to be seeing, I think on My Math Lab, instead of writing the word or, sometimes they use that union sign. Following the same procedure, 2x minus 5 is greater than 3. All I'm doing is dropping the absolute value sign. And then I say 2x minus 5 is less than negative 3. Once again, following my rules for absolute values, it could be 3 or it could be negative 3. And once again, I'm flipping greater to less than because I threw in a negative sign, and that means take the opposite of greater, which is less than. And then I have to decide, should I write the word and or? And since this sign is a great or, I will write the word or here, and all of a sudden I already know what the graph is going to look like. Off to the left and off to the right. Let's see if we can figure out at what values. So, that's not true. I don't want to do that. I want to add 5 to both sides. How about 8? Oh, this is better. So x is greater than 4. Or, we'll try this again. Adding 5, x is less than 1. So it's an or statement, so I'm going to say it goes in opposite directions. So here's the 1, here's the 4, and I'm going in opposite directions. Again, to write this in interval notation, I'm going from negative infinity up to 1, or in union with 4 to infinity. Always put the lower number on the left and never put a bracket on parentheses. You can never close. This one I'm using parentheses because I'm not using these equal signs. So if there's an equal sign, then I'd use a bracket. If it's just greater than or less than, I always use parentheses, which means I can only use those values up to. So you can try this problem. Go ahead and hit pause on the video and see if you can choose a multiple choice because your tests will be multiple choice. I hope you're done with this problem because I'm going to share the answer. I hope everyone got answer C. So that kind of concludes section 1.6. If you have questions, email me or join me for my office hours on Tuesdays evenings at 8 p.m.